What are classes? Let's take a look at the class structure in C++. And we had talked about this in Java before, but most object-oriented languages have some kind of a class type structure. Now, before C++ and old C, you had a structure, but a structure would pretty much just combine data members, not functions, together into an object. A class in C++ is sort of an extension of the idea of a structure, but it's a little bit more sophisticated and a little bit more closer to the way things are in the real universe. In other words, an object in our universe, take, I don't know, an atom or a star or a person or a dog or a cat. You don't separate what an object is, its attributes, its data members, from what it does, its functions, its methods. That object is the sum total of both what it is and what it does, or what it's capable of, okay? The nouns and the verbs that make up that object. So that's kind of the idea behind a class as far as its extension of the idea of a structure. So I'm going to make a new project in Bloodshed, and later we'll open up Visual Studio and we'll look at inheritance and classes in Visual Studio as well. But I'm using Bloodshed for a few of these because it's a free compiler. It doesn't cost you a dime. Now I recommend probably eventually getting some version of Visual Studio. There are trials and free versions and student versions and all kinds of things you can get out there. But this is great. It's an open source compiler. It's based on the GCC Linux compiler. And because it's open source, it's all free. It doesn't cost anything. I'm going to build a new console application, and we'll call this one classes, just to illustrate the idea of classes. Okay, and I'm going to just throw it in this folder here, someone with the pointers. Okay, and just to illustrate in main, alright, so that'll let us know that we're in main. And when we drop down here, I'll drop a line or two. That way when we see the pause, and then any code we want to play with, we'll put right here. Okay? So this will be sort of our main function for demonstration purposes. Okay, so basically when you write a class, if you want to think of what a class is a user-defined or programmer-defined data type. Now, what's a data type? You'll remember. That's like an integer. C++ and Java are what we call strongly typed languages. And the reason is because different variables, different data types consume different amounts of memory. Like integers are 2 bytes, or floats 4 bytes, or doubles 8 bytes. And it depends on, a character is 1 byte, and a string is a byte for every character in the string. So, and user-defined or programmer-defined data types classes could be hundreds or even thousands of bytes. So there's all these different size containers, these different combinations of bytes and 8 bits each. And so it's important the kind of object that we store in a variable. The variable has to be the right data type, the right size to accommodate the values, the data we're going to store inside of it. But we talked a little bit before about the process of instantiation. Well, if I want to make an integer called x on the stack, I could say int x equals 10. And that builds an integer on the stack, and that'll store the value 10 inside of it. Instantiation. The process of building an instance of a data type. First, we'll see how this works with simple data types. Now, previously we were discussing pointers and passing by reference via passing by value. Well, we're going to look at different ways to build objects. We're going to look at creating our own classes and building objects on the heap, the free store, versus building objects on the stack. So first, we're going to take the idea of a structure, and we want to extrapolate or kind of build on it for classes. So if you think about it, if I were going to build an integer, okay, then to build that integer, I would use the data type int, and I would declare, let's say, x, and I want to store the value 10 inside of x, okay? So if I did that, this is x on the stack. It's an integer. I'm storing the value 10 inside of it. Well, this is a simple data type. It's predefined. It exists in C++ already. I could do that with a double. Y is equal to 34.567 or something if I so desired, okay? I could do that with a character. Alright, I could do that with the character array. Alright, my string, okay, if I wanted to. I could do that with the string class object. Right, string data 1. So these are all predefined objects, not objects that I created, but the process of instantiation, or making the object, is relatively the same. It would be the data type, and then the actual object I'm building. Classes are blueprints for objects we want to build in memory. Let's look at creating and defining a class specification. Well, a class is a data type that we create. So, for example, let's say we were going to build a monster. All right, I'd use the keyword class, and I would name the class. The code would go inside of open and closing curly braces, and I would terminate it with a semicolon. Okay, and then classes follow an idea or a philosophy, a principle of something we call encapsulation. Right, encapsulation. And the idea behind encapsulation is to combine what an object is with what it does. Okay. All right, and there are ways of setting up classes or defining classes both inline and outline, but we're going to do inline right now because it's kind of a simpler way to create a class. And when I get time later, maybe we'll do some outline definitions and things. You'll see both when you're going through different kinds of C++ code. So here, this is what we call our class specification. It's empty. Now every class has modifiers. Okay. So in this case, we're going to start with a public modifier, which means that the items under public until we change it to private later are easily or readily accessible. And every class has what we call a constructor. And the constructor is a very special function that has the same name as the class. Okay? Always the same name. And unlike other functions, normally if I have a function and it doesn't return a value, I have to put void in front of it. But that is not the case with the constructor. So I can just type out the function name and then some parentheses. And you can do all kinds of things with constructors. They run automatically. Whenever you build an object from a class, the constructor gets called. But usually what I do is I throw some code in there just to give me some feedback. And that way later if I build up an inheritance hierarchy or something, then I can kind of see when one object as a parent builds or is used to build another object as a child object and so forth up and down the hierarchy. So I'd usually say something like this, and then I might pull that code out in the finished product, but we'll say building a monster. Okay? Say building a monster there. That's all. So at this point, that's all the constructor does. Okay? And the constructor, its job, I'll throw a little comment tag in here. Its job is to run automatically when the class is called. And the constructor is used to build that object. Now, when you write a class, it's not an actual object. It's a blueprint for an object. So the analogy we could make is, imagine that you had CAD software and you designed your dream house. Really awesome house. Okay, well when you get done, you have the plans for building a really awesome house, but you don't have an actual awesome house until you get the resources, the wood, the money, the construction crew to build it. And then they would take your blueprint and they would construct or build the house from your blueprint. Well, when you write a class in C++ or Java or other object-oriented languages, it's the same thing. You're making a blueprint to build something. And I didn't spell that right, did I? Can't walk and chew gum at the same time. All right, so you're basically creating a blueprint, and from that blueprint, you will build, create, construct an object in memory, okay, with resources, CPU cycles, memory, and so forth. So that constructor gets called when you create that object. Now, there's also something called a destructor, and it's the same as the constructor, but it has a tilde in front of it, but it would have the same name as the class, no return type or even void in front of it, and it gets called whenever the object is destroyed. So if I created a monster locally in a function, remember when a function ends, all the variables local to that function are destroyed, and the memory is released or freed. And so typically, again, when I'm debugging, I'll put a little bit of debug code in a destructor and just say, hey, I'm destroying a monster. And it'll let you see, if you get null pointer errors or something's wrong in an inheritance hierarchy and you're trying to figure out, what's wrong when you're building or destroying different objects, This can really help you as far as, sometimes tracking things down. You might pull them out or comment them out in the finished product, but a lot of times it's typical to do that in the constructor and the destructor. All right, so every class, at a minimum, would would need a constructor and a destructor to run when that object's made and when that object is destroyed. And in addition to that, you may have functions, what we would call member methods. Right? And what would they be? Well, let's make a void. Every monster has the ability to, let's say, rampage through the city. Okay? And if that were the case, then right, monster rampaging through the city. And that would be what we call a member method, okay? Now, in addition to those public items, constructor, destructor, member methods, every class has private data. Now, don't get me wrong. There's no, there's no fundamental rule of physics or the universe where you would be struck down or where your program wouldn't work if you chose to make your data public. You could do that and access it directly, but it's considered bad form. The accepted practice for coding a class, its data members, is to make them private. And that means something. If an item's declared as public, then that means it can be readily accessed outside of the class. You don't have to go through any special functions to get at that piece of data or to call that method or that function. But if an item is declared to be private, in other words, let me pull out these comment tags, then I can only access it directly when I'm inside the class. When I'm outside the class, I couldn't, I'd have to go through a public function to get at that private data, a function that was in the class. And you're like, that's madness. Why on earth would anybody want to do that? Well, the idea behind it is that in C++ and Java and other object-oriented languages, you make your data private, it protects it, it kind of secures it, and then you use public functions to access it, and they kind of act like a gateway to control access to that data. And it might not be such a big deal in a small project, but imagine a larger project where you have hundreds or thousands of objects, monsters, if you will, running around. We wouldn't want one monster inadvertently, accidentally accessing the data members of another monster. So, in other words, let's think of, we'll continue defining our monster class, and we'll illustrate this further as we go. So, the methods, those are the verbs. Those are the things a monster does. All right, what are the things a monster is? It's attributes. Well, every monster has a certain amount of life or health, and we could represent that with an integer, right? Every monster has size, and we might represent that with a double. Every monster has weight. We could represent that with a double. Perhaps every monster has a name. So what if we represented that with a string object? Okay, and we could do that. We could say string monster name. And so forth. There are plenty of other data members that we could ascribe or give to a monster, but that kind of illustrates the point. So if those data members were private, now we need what are called accessor methods in the public area that come under here, under this public label, to access the data here under the private label for every class. So once I figure out the attributes, the data members that are going to go inside of a class, then I'm going to come back in the public area and I need to write accessor methods. And accessor methods are just very simple functions or methods whose sole purpose is to be public and to allow either retrieving or setting of the private data in the class. And they simply need to agree with or match the data type. So in other words, if I look at life, and typically I prefix these with get and set. You don't have to. You can call it banana if you want to. But it's sort of traditional. That way you can quickly look at a function and you know, hey, this is the set and that's the get. If you prefix it with that. So we'll take the first one, life, and let's look at the get. The get means I need to return a value, right? And I can't return a string or a double or character. I have to return an integer, because that's what kind of variable life is. That's the way life rolls. So in this case, int, and I would just call it get life, or get a life, or whatever you want to call it. And it's a very simple function. All I have to do is say return life. But this needs to agree with the data type that life is. You know what I'm saying? Now, I don't need to take any arguments or parameters because I'm not changing life. I'm just simply getting the value of life and spitting it out, returning it via a public function. All right, so the next one we want to do is a set. For a set, I don't have to return a value. It's not that I'm spitting out a value. Data's coming in, not going out. So my return type can be void, but it's sort of the inverse or the flip side of the get because the set needs to accept an argument or a parameter, and it has to match the data type. I couldn't take a double as an argument or a string. It has to be an integer, right? So int, and you can call it anything. I usually call mine x. And then again, it's a very simple function. All I have to do is take life, goes on the left, that's the private data, and the public data comes in and it's on the right, in this case x. Alright? And so this allows me to use a public function in my public space to manipulate or set private data in my private space. So it sort of acts like a gateway. Alright, so for size and weight, I do the same thing. And it just needs to match the data type, right? So double. I'm going to do, in this case for the get, I need to match the data type. It's going to be a double. And it's going to be get size. I don't need to take any arguments, right? Didn't have to appear either. But I do need to simply return the value of the private data. So again, I'm just going to say return and size. Okay. Now what about set size? Set size? Well, it's going to be void. And I'm just going to prefix it with set. You can call it banana if you want, but now I don't have to return a value, but I do need to take arguments, and they need to match the data type. So it needs to be a double. And I can call it x or whatever. And again, the private data on the left and the public data on the right. So size, and I just assign the value to size. And if I were to do weight, alright, coming in, same thing. It just needs, I need to give it a different name. The get has to return the right data type. Weight's a double. The set doesn't have to return anything, but it has to take an argument that's the right data type. And I just want to change these variables instead of, since I copied and pasted. Only problem with copying and pasting if you forget, but I want to make sure that I return weight and set weight and not size. Alright? And then the last is a string. So again, here, you tell me, what would we use for monster name in this case? How do we write the get and the set? Well, the get needs to return a value. What kind of value? A string, right. Alright, so I have to, not star ring, but a string. Okay, and then you can call it what you want, but how about get monster name? Extradition. Okay, I don't need to take any arguments, and the action of the function or method is very simple. Just a keyword return and monster name. Okay, so I'm going to return monster name. And what about the set? Right, you guessed it. Don't have to return anything, so it can be void, but I do need to take the right kind of argument or parameter, right? So if I were to call it set monster name, then I have to accept a string as an argument, and I can call it x. And again, private data on the left and public data on the right. Okay? So now I have public accessor methods, a get and a set, for each piece of private data in the class. And large complex classes could have hundreds of data items or data members, and hundreds of accessors to get at them, as well as member methods, all kinds of things. But that would be our basic monster class, right? So if that's our basic monster class, and it's defined up here, how would we use that class of object? Well, it's just a blueprint, but we don't have an actual monster yet. We haven't built one. Well, let's check our syntax at this point. Maybe we could have semicolon or brace issues or left something out. So we'll check this out real quick. Let me do this. We'll call this okay. So our class is okay. And just to illustrate the definition, I'll throw a couple of comment tags in here too. Might make it easier. So comment tag there, comment tag here. Alright, so there's our class definition, but it's just a blueprint for our monster. We haven't actually built a monster yet.
Building an object from a class. Instantiation.
So how do we build a monster? Well, how do we build an integer? How do we build a double, a character, a string? On the stack anyway. Let me write that here. On the stack. Exactly, you guessed it. So the name of the class is monster. So just like integer, double, character, these built-in data types, one that we create, a programmer-defined data type, would be the class name, and then an instance name. When you instantiate it, you give it an instance name. So we could build Godzilla, or Bob, or Joe, or Mothra, or whoever you wanted to build. That would actually build a monster. Okay? And if I did this, what's going to happen? When I build a monster, it will call the constructor, and we should see building a monster. Not much else is going on, but let's build the project and check it out. Alright, so welcome to classes and main, building a monster. So there's our constructor.
Let's see how we access member and accessor methods from objects created on the stack.
So once we build the object, how do we do something with it? How do we get at its data? What it is, its attributes, or how do we call its methods and functions and get it to do the things that it can do? Well, if you build something on the stack, like we're doing here, it's via the dot operator or the period. So in other words, I take the instance name, not the class. In other words, I wouldn't say monster dot something, but the instance, the actual object that I built from the blueprint that we wrote, Godzilla, and I would say dot. And that would give me access to anything that was public, not private, but anything that was public inside the monster class. What's public? I have all these public accessor functions, a member method, but that will allow me to get at the private data. So let's say we want to set these data members as we go down. First is life. Well, what is it expecting? The one we wrote to allow us to change the value or manipulate the value of life is called setLife, and it expects an integer. So I would call it via the instance name, which is Godzilla dot and setLife, and I have to pass in. I couldn't pass in a string. That would be wrong. It has to match the parameter or argument list for the accessor function. But I can pass in a number, whole integer value. So 500 will be the life for Godzilla. Okay, so that's what it's expecting in setLife. Now let's go through and do the other pieces of data. So size, weight, they need doubles. If you look at the sets there, a monster name expects a string. So the same thing, right? Godzilla and set size and Godzilla set weight and set size, set weight, and let's see, the last one was monster name. Alright, Godzilla set monster name, and of course Godzilla's name is Godzilla. And the size, good grief, I don't know, how big is Godzilla? I don't know. Let's say Godzilla is as tall as a 100-story building or skyscraper. What would you say that would be? Make him 1,000 feet tall. Godzilla's weight in tons. I don't know. Let's say 5,000.8 tons or something. Who knows? Who knows how big Godzilla is, but whatever. Alright, so this would be an example of using or calling the sets and creating or building an instance of Godzilla on the stack. Okay? Now, let's write a function, and we'll put a function inside of Godzilla to display the stats. Alright, so I'm going to put it here under the member methods, and we'll call it display stats. Alright, and all we're going to do is display the data members of a monster object. That'll be the purpose of this. Alright, so now, because I'm inside the class, I don't have to go through the public accessors. I can actually call the private data directly. But when I'm outside the class here in main, I have to go through the accessors. And that's the idea. That's what we want. That's the convention. Okay? So monster name, but I can do it directly here, and I shall. And we will simply display the pertinent data for our monster. Alright, so that was name, life, and we can display life. And let's do size, and we'll do weight. And weight. Okay? So those are the pieces of data that we, that would be a monster for us, or what we want to display. And maybe we'll just add, when we call that, we'll add another line. And let's see, 2 of those. Alright. So that'll be our display stats function. So if we do this, now how would we, once we set all the data on our monster, we build it, we set all this data, we can display our monster if we, again, using the dot operator. Now would it be monster dot display stats, or would it be Godzilla dot display stats? Exactly, right. It's not the class name, not the blueprint, but it's the actual instance built in memory from our blueprint or class. So it's the instance name. So Godzilla dot display stats. Okay. And let's check our syntax. We might have a few syntax errors. We'll build the project. Looks good. Let's run it and see what the effect is. Okay. Alright, and I'll just modify the background a little bit. Help you guys try to make it more contrasting there. Alright, so here's our constructor building a monster. We set all the data, and then we call display stats, and there's our monster's name, its life, its size, and its weight. Oops, little typo there, but you get the idea. We'll go back in our class and modify that so it doesn't say sweight, but weight. Okay, so that's the idea behind building an object on the stack.
Now let's look at accessing member and accessor methods from objects created on the heap.
Now what about the heap? Remember the heap or the free store? We said everything you build on the heap or the free store works by pointers, but it's much more efficient. Remember we said that the stack, you're moving things up and down the stack, and it's very expensive in terms of CPU cycles and memory sometimes, because objects can be large, and you're moving objects all over the place around on the stack that consume system resources. Now pointers, on the other hand, the heap, the free store, it's very efficient. So let's take a look at that. The heap, or what some call the free store. Okay, the heap or the free store. If I were going to build a monster, we'll build Mothra. Well, the way that works, everything on the heap or the free store works by pointers. So monster, Mothra, and we're just going to build a new monster. Alright, this pointer here, for the duration of our program, or for the life of the monster on the heap, will be used to get at that monster. And I want to be careful not to reassign it to something else without destroying this or cleaning this up, or this will create a memory leak situation, because we'll have an object built on the heap that we can't necessarily control or access anymore. It'll be consuming memory, taking up resources, but it won't really be used for anything. So be careful about reassigning pointers when you build things on the heap, unless you destroy that object and set the pointer to null. But for now, we just want to build Mothra on the heap. So that pointer will then do that. Now once we do this, I can't use the dot operator. Like here I built Godzilla on the stack and I could say Godzilla dot. So you would think that I could say Mothra dot, okay? And as a matter of fact, if you were in Java, Java does build things, in sort of almost its version of a free store or heap. You use the keyword new, you call the constructor, just like you do here in C++, but you use the dot operator. You don't use the arrow. Well, in C++, you use the arrow when you build something on, the heap or the free store. So normally I'd say Mothra dot and all those functions. Well, now I have to use the arrow. So let's do the same thing that we did up here. Okay, I'm going to copy and paste. But we need to modify this to work with the stack and also with our pointer. First off, it's not Godzilla, it's Mothra. So I'm going to change Godzilla all the way down. Okay, so that was first. Second, Mothra is not an actual monster object on the stack like Godzilla is up here. Instead, Mothra is a pointer that points to a new monster on the heap or the free store. And because of that, I cannot use the dot operator. I have to use the arrow. But when we start coding MFC applications and .NET apps and the .NET framework, you'll notice that a lot of these utilize indirection and pointers. And so they'll build things on the heap or the free store, and therefore you have to use the arrow to get at different functions with those items. Okay. And then, of course, if we do this, we want to change everything appropriately. So instead of Godzilla, Mothra, and again, I don't know how much Mothra weighs, but I'm sure Mothra weighs much less than Godzilla does. I mean, after all, she does fly. All right, let's say 1,000.5 tons or something. The size, Mothra is big, but I don't think she's as big as Godzilla. So instead of who knows? Instead of 1,000 feet, maybe she's 800 feet, or maybe 500 feet or something. Who knows? And then her life, she's not necessarily as tough as Godzilla, is she? Tougher than your average monster, but who knows? So if that were the case, just notice the difference, because Mothra is a pointer to a monster on the heap, whereas Godzilla is a monster built on the stack. And if that's the case, then how would I call display stats on Mothra? Right, you guessed it, the arrow. Okay, Mothra's a pointer, so it'd be Mothra, the arrow, and display stats. So again, let's rebuild our project and check for any syntax errors we might have. And let's run the project and see what happens. Okay, so we build Godzilla, and here's Godzilla's stats. We build Mothra, and here's Mothra's stats. We're effectively achieving the same thing, but this way of doing things is much more efficient in the long run than is this way of doing things. You'll see both when you're looking at code, but this is probably what you want to do most of the time, because using the heap and the free store can be a lot more efficient as far as maximizing the usage of your memory, your CPU cycles, your system's resources, than would be maybe creating objects on the stack like you do here.